Alright guys, welcome back. So in this video, we're going to be looking at classes in Python, and this is where stuff gets a little bit hairy, man, in programming. Python's class-based programming is not necessarily the same as other object-oriented languages. Python's considered object-oriented, but it's not completely object-oriented. We've seen that we can write code that has nothing to do with classes and objects and things like that. But let's go ahead and define, what is a class? And a class in Python is simply a set of blueprints. So if you're an architect and you're designing a new building, you're going to have on your little rolled out paper your blueprints of how that building is constructed. That is your class. It's just simply instructions to say, hey, when I build this building, these are the instructions that you follow to build it. The actual, what is considered the concrete implementation of a class, which all it means is stamping out a new object based on those blueprints, is the actual class object. So that's where it gets into this object-oriented programming. Objects are supposed to be these isolated sections of code, and you're supposed to just be able to plug in objects, and objects should communicate with one another, and they shouldn't be interfering with what each other are doing in a truly object-oriented, nicely designed program. So these blueprints, though, is where we start, and that's actually where we're going to create our class in Python. So Python has a simple class keyword, and then after the class is going to be the class name. Now the class name in Python typically follows a Pascal casing naming convention. So if I were going to say person should be capitalized. If person had if I had two words, I said like person, I'm trying to think of an example. Person cereal or whatever. That's a dumb name, but basically you would capitalize each word in your class. Now in classes there are no parentheses after them, so we just simply say person and then colon, and then down here, this is where we can actually have a class method. And once again, the class method is basically a function that we discovered in the previous video to this, but when they're attached to classes, I consider them class methods, but they could also be considered class functions as well, but if that's what you really want to call them, but proper terminology should be method. So let's go ahead and create a class method, and we're going to say define print name. And here's an interesting thing that we're going to end up that's going to come into play here. Number one, I like to define this as just this underscore. I think that's more Python convention based, but some people might do this because that's the way they like to do it. Some people might do camel casing, which is like that, but typically you're not going to see that in Python. I would just stick with the underscores for now, but depending on whatever sort of Python group you're working with, they might tell you to do something differently, but this is how I would define my class method. And then inside of here, the interesting thing is that we're going to have to reference a value which is called self. And this is something that doesn't make any sense to anybody when you're first getting involved in this. And even after like 2 years, you're still going to be like, I still don't understand why the hell we have to do that. But self is actually representing the object that is being stamped out from your blueprints. So this is simply a rolled up piece of paper giving instructions. This is a method here, but this right here, this self, is the actual object that got constructed from the class. Oh my goodness, that is a lot to swallow. But let's just say, for right now, we're going to say print Chris Hawks. I feel like I'm full of myself or something. I'm not trying to be full of myself by like printing my name, but that is my name. So you guys got to say it. Just say it over and over again so I can hear it. I'm just kidding. No, it's not like that. It's just simply that is my name. And when you guys are following along, you'll probably use your own name. So here, let's go ahead and create our object from the blueprint. So how do we do that? We're going to say Chris equals person, open and close parenthesis. That's simply it. Chris is now an object that got stamped out from the blueprints that is person. So if I said Chris dot print name, I would call it as a function because it's a class method. It's basically a function attached to my class, and I call it that way by using this dot notation. So Chris is referencing this method. That's how you call it, and all this stuff is just encapsulated, which means like sealed into like a pill that is a plastic pill that holds all the medicine inside. It's all just encapsulated inside this person, and all your functionality. Person could even be in a separate file, and we can import as we've seen. So let's go ahead and put a breakpoint here and run our file. And also, by the way, I'm working out of this second file. I created that in one of the previous videos to this one. So now when we look at Chris, you can see Chris, and there's this weird, if we hover over it, it says main.person, see look, object at blah, blah, blah. What is this garbage? This is actually Python's memory locator or a pointer. This is the object, and this is the place in memory where Python can find the object that got stamped out from the blueprints that is person. So every time you create a new object, you're going to have a different memory location right here. So now if we highlight over Chris, you can see it's person object. So let's go ahead and put a breakpoint on person. Watch what happens when we press play. It hits this define print name, and it's going to print out Chris Hawks now. But look at self. And does this look familiar? Self? Self is the object in memory. So if I hover over it, it keeps disappearing. But you can see that is the same object. So self got assigned the object that got created. That's weird, but that is the reason why you need to reference self. It's important, and we're going to see a demonstration also why self needs to be there. Now you can see it prints Chris Hawks. So if we wanted to define a name to the person, we could say, I'm going to do this a long roundabout way so you can see a reason why something exists here in just a moment. We're going to say assign name. We're going to say self. And inside this, we're going to say self.name equals Chris Hawks. Now, in print name, we can, instead of printing out Chris Hawks, so we're going to say print self.name. So now, if I do this, we need to actually call assign name before we try to call print name, because it has to assign the value to name before we try to actually call it. Otherwise, we're going to end up getting an error. So let's go ahead and we're going to put breakpoints right there, and we'll press play. So now assign name gets called first, and it just simply takes self.name and it attaches it to this object. So if we looked at this object and that it's named Chris, we could see name. There's now this name value under there, and it's assigned. And the name is just a variable, and it has the Chris Hawks value. So now when we say print, you're going to now see self.name is Chris Hawks, and it prints out Chris Hawks. So that is not the way that you would normally do this, and the reason why is because it's not very flexible. Why would you create a generic person which could represent Chris Hawks, or it could represent whoever's watching this video? It could represent any person on the world. But I just went ahead and hard-coded the name Chris Hawks to it. It makes the code very unusable and unfriendly to share and stuff like that. So what you would do instead, you would reference a constructor class method called the init method in Python. And it's a really weird thing, but it says define, and this is double underscore. So underscore is basically where we do the minus, except you're going to press shift and it does this underscore. You need two of them, and you're going to say init. And then inside here, we're going to say self. And now we're going to say name. And then inside this init, this is where we're going to actually define self.name. So we're going to say, self.name equals name. So now what is this init doing? We no longer have to actually pass this value. We could actually pass it from within person, and we could say person, and then we'll say Chris Hawks. In fact, I'll do proper capitalization, Chris Hawks. So now when I create my person object named Chris, I'm passing in its name, and it's going to return the value. So when I say Chris.print name, call it as a function, and we press play. Let's go ahead and take a look here. And you know what? I want to put a breakpoint right here on the init. So what happens? Init got called. Here's the object in memory. Here's the name. So how did name get passed in? Well, it got passed in right here. Why didn't I have to pass in self? Just because you don't. Self is always there in a class. Self is the object in memory that got stamped out from the blueprints. So you don't have to say self in here. In fact, if you pass self, self is going to be assigned to the name parameter. So don't do that. But I created a class and I gave a unique value, and it got assigned to name. We then attach it to our object under name, and then we can reference it throughout our object now. So I don't have to say self-assign or anything like that. It got called automatically when Python created a new object. So I didn't have to say call init or any of this other crap. And most of the time, you're going to actually say, there's going to be all kinds of stuff that you can do. Hair color, height. And now this person could say self.hair color equals color self.height equals height. And now I can actually pass in more things. So I'll say brown. And then my height is about 6'1". That could be a string, or I could even say, yeah, I'll just do string, make it easier. So my height is 6'1". And now if I said print name, and we could even create a new function that says define print height. And we're going to reference self.height. And then we could say print hair color hair color. All right, so now if I want to say Chris print, we'll say hair color, and then we'll even go down here. Actually, we'll do all three: hair color, height, and name, right? Yeah, there we go. All right, so let's go ahead and run these. Oh, name color is not defined. Why is color not? Oh, wait. Oh, because, yeah, see, you guys probably noticed that. All right, no problem. That's because we try to reference color instead of hair color. Color would be racist. A string object is not callable. Where are we? It says line 20. Here's... All right, yeah, sorry, guys, I'm being stupid right now. This is print hair color, print height, and print name. And by the way, it's good when we run into these error messages, but it tells you right there, it says line 20, string object is not callable. It didn't know what you were trying to do because we didn't actually say the function or the class method name correctly. So now if I run this, it prints out all those stats. So now we have this class, and this class could exist in its own file, but it's much more flexible to be able to work with any person that you want. You could have thousands or millions of persons stamped out. This could be an employee database that exists for all the employees in your company, and this is object-oriented programming, guys. This is all about creating these blueprints and then constructing and interacting with them in a certain way. And obviously, your functions can do more complex things. You could have in your functions another value. Like, so if I were to say print name another value, I could say print name plus another value. So you could, and then call Chris.print name and then pass in another value. Or I'll just say this is some more crap. And you can see when it calls print name, we'll put a breakpoint right here. So when we call print name, you can see another value got passed in. So it's going to take its name, Chris Hawks, and then add this value, print it to the screen, and it's all down here. So you have all kinds of flexibility in order to be able to, to do stuff. So this is, I think this is a good demonstration, guys. So let me know what you think. Please subscribe to this tutorial series, or actually my channel. And please upvote. If you guys have any questions, just reach out. Thanks. Bye. Hey guys, so a lot of you ask me, how do I get my foot in the door to become a programmer? And I just want to take a moment to mention Dev Mountain Coding Bootcamp is a 12-week intensive course that focuses on the technologies of the here and now for web development. Some of the things that they're actually teaching in this 12-week course, it's geared to get you into the industry by focusing on things like jQuery, Node.js, React, Angular, how to use GitHub. So a lot of the things that you're going to need to do as a developer, as soon as you start, they're going to be teaching you in this coding bootcamp, and the entire goal is to be able to get you into the industry within 12 weeks. So if you guys are interested in learning more information about Dev Mountain Coding Bootcamp, just check out the link in the description tab of this video. Thank you for watching, and have a good day.